In the last episode, we left our Wait on Planets application in a working state, but it arguably needs a lot of cleanup. On top of that, it doesn't handle all possible user interactions. Let's start tackling the way we're fetching the parameters. We're matching the query string against a regular expression, but this could be abstracted. Webpipe comes with the params extension, which we can load on demand. It adds a params method to the connection struct that returns a hash with all get and post parameters in the request. Even if there's nothing wrong with using a string for the hash keys, in Ruby we're more used to use symbols for this kind of behavior. We can configure the params method to work in this way. For that, we are going to use what we call a built-in plug. A plug is just a step generator, and in this case, we need the one called config. It makes it possible to tweak the behavior of some of the extensions. When it comes to params, it allows us to register a pipeline of transformations on the hash. Internally, this mechanism is built leaning on dry-transformer library, so all hash transformations available there can be used along with the option to define your own. Just a quick notice, we are now using Bundler to manage our dependencies in a solid way. We've declared our dependencies in the gem file, so Webpipe can find dry-transformer. We can now use deep symbolized keys transformation from it. Let's move on to how we are dealing with the structure and coercion of these parameters. For now, we are just assuming that we have the parameters we need, so if we forget to provide any one of them, it will make our application crash. When it comes to coercion, we are doing it manually at the moment we fetch them. We can do better and be more explicit along with leaving gates open for more flexibility. There's no better library for that than dry-schema. We define a minimal schema and we apply it in a new step. If the contract is met, we add to the struct the sanitized result, and we fetch the input from there. Otherwise, we halt the execution with an error message. However, Webpipe comes with a dry-schema extension that already streamlines this process. We can sanitize the parameters through the sanitized params plug, and then fetch the result through the sanitized params method. We can configure a callback that will be invoked when the contract is not met. It must be registered under params sanitization handler key, and it takes two arguments: the connection struct at the moment we call the sanitized params plug, and dry-schema result. Now let's look at the URL we are using. We can all agree that it's rather ugly, and we could benefit from reading the user input planet and weight from URL slots. For that, we can use the router params extension. It doesn't do anything too fancy. If we add a parameter transformation called router params, it merges what is present in router.params rags environment hash key into the parameters. All of this integrates out of the box with hanami-router library. Until now we haven't used any kind of router, so all requests to the server ended up within this class. Hanami-router is a RAG application itself that can delegate different URLs into other RAG applications. Let's rename our to wait and leave app for what is generated with hanami-router. Let's use planet and wait placeholders to be used as our parameters. We can try it now and see how our URL is much more user-friendly. Thanks for watching this new episode. Remember, you can find the code on GitHub. See you next time.